2025 A-Level Combined Mathematics Paper 2 Part B, question number 14, Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with coplanar forces and their equilibrium. The question says, ABCD is a plane quadrilateral with BAD angle equal BDC angle equal pi by 2 radians, AB equal AD equal 2 root 2A and CD equal 3A as shown in the figure. The forces of magnitudes 3p, 3p, 2 root 2p, 5 root 2p and 3 root 2p act along AB, AD, BD, BC and DC respectively in the directions indicated by the order of the letters. So basically if we have AB, it means the force acts in the direction from A to B, or basically if you take the AB vector, then that direction is the direction that the force is applied in. It says this system of forces is equivalent to two forces of magnitudes alpha p and beta p acting along AB and AD respectively in the directions indicated by the letters and together with a couple whose moment is m acting in the counterclockwise sense. Now given all this information, we are asked to find the values of alpha, beta and m. And then it says, now a couple acting in the plane of the quadrilateral is added to the above system of forces such that the resultant of the new system of forces goes through the point D. Given this information, we are asked to find the moment of the couple added. Now to solve this question, first off, in the diagram that we are given, we are missing some geometrical facts. For example, we are missing this length and also missing some of the angles. So if we go down and first fill those in, this angle here is going to be pi by 4, and you can tell this angle is going to be pi by 4 because it's less than 90 and greater than 0, and because the tangent of the angle is 2 root 2a divided by 2 root 2a, which is 1, and therefore the angle here is pi by 4. And also of course that means that this angle here is also equal to pi by 4. Now furthermore, if you consider the hypotenuse here BD squared must be equal to AD squared plus AB squared. So if you take this thing, 2 root 2a squared is going to become 2 root 2 times 2 root 2, which is going to be 8 times a squared. So here we have 8a squared. This is also going to give us 8a squared. Added together, that's 16a squared, meaning that BD squared is 16a squared, meaning that BD is going to be 4a in length. Now for the second triangle, here we have 3a, here we have 4a, and as we know, the common triangle, the right angle triangle 3, 4, 5 indicates that this side length should be 5a. Of course, you don't have to do that. You could do bc squared equals 3a squared plus 4a squared. 3a squared is going to be 9a squared, and 4a squared is going to give us 16a squared. Added together, that's 25a squared, which is going to give us 5a as the side length here. Now additionally, we don't know this angle, but we can call it theta, and we can see from the triangle that the sine of theta is equal to 3a over 5a over 3 over 5, and the cosine of the angle theta is equal to 4 over 5. Now that we've established the geometry, we can move on to handling the forces. So it says there are 5 forces in total. We have 3p, 3p, 2 root 2p, 5 root 2p and 3 root 2p in the directions AB, AD, BD, BC and DC. So first off, AB and AD have 3p forces in them. So AB and AD means A to B and A to D. These two directions, there's a 3p force in this line AB, and there's another 3p force in the direction of AD. And then there's a 2 root 2p force in the direction of BD. So B to D, BD, this direction, there's a force of 2 root 2p, and then there's a force of 5 root 2p in the BC direction. So from B to C in this direction, 5 root 2p, and then finally in the DC direction there's a 3 root 2p force. So in the DC direction the 3 root 2p force, and those are all of the forces in the entire system. So now they're saying this is equivalent to alpha p plus beta p and another moment of m, the alpha p being in the AB direction, the beta p being in the AD direction, and the m being a moment in the anticlockwise direction. So basically we're saying this entire system of forces is equal to a force at A going in the AB direction of alpha p, AB if alpha p, which means there's a force in this direction of alpha p, and then there's a force in the vertical direction from AD, A to D, AD of beta p, so upward force of beta p, and there's also a moment m in the counterclockwise direction, so anticlockwise like this is a moment of m. So these three are equivalent to all of the stuff we have here. Now, given that, we can form some equations that we can use in order to find what beta p, alpha p, and m are. The equations we can form here are the fact that if you take the moments in any particular point, or you resolve in the let's say the rightward direction or the upward direction, you're going to get the same values in this system of forces and this system of forces. So using that, if we start resolving, we can say resolving. If we do it in the horizontal direction, we'll get one equation, and if we do it in the vertical direction, we'll get another equation. Now, doing it horizontally, the sum of all horizontal forces must be equal to alpha p. So therefore, if we resolve horizontally, we get alpha p equal to, and the sum of all horizontal forces in this system, which if you take a look, we have 3p in this direction, the rightward direction, so 3p, and then this 3p force doesn't do anything since it's vertical. Out of the other forces, we have 2 root 2p in this direction, so we need to take the cosine value of that in the horizontal direction, so cosine of pi by 4, so we have 2 root 2p, so plus negative 2 root 2p cosine of pi by 4, and it's negative of course because in the leftward direction, but we took the rightward direction as being positive, so you can see negative 2 root 2p cosine pi by 4. Now then we have 3 root 2p in this direction, and the angle of it, since this angle is pi by 4, if this angle is pi by 4, then this angle is also going to be equal to pi by 4. So therefore, we need to have the cosine component, which is going to be 3 root 2p cosine pi by 4, and it's in the positive direction, so we have positive 3 root 2p cosine pi by 4. So we can write plus 3 root 2p cosine pi by 4, and then finally we have another 5 root 2p, it's in the negative direction, and we need to take the cosine component in this direction where this entire angle is relevant, which is the angle pi by 4 plus theta. So therefore we need minus 5 root 2p cosine of theta plus pi by 4. So we have minus 5 root 2p cosine of theta plus pi by 4. Now that's what we get if we resolve horizontally. Now let's do vertically. If we resolve vertically, we're going to get beta p on the left hand side. So we have beta p equals, and on the right hand side, this 3p is not relevant since it's in the horizontal direction. This 3p is relevant since it is perfectly vertical. So we have 3p. And then in terms of the other forces, we have a 3p, which we have to take the sine value of pi by 4. So 3 root 2p sine pi by 4 plus 3 root 2p sine pi by 4, and then we have 2 root 2p, it's also vertical, so we have 2 root 2p's sine value, 2 root 2p sine pi by 4 plus 2 root 2p sine pi by 4, and finally we have a 5 root 2p that is in the vertical direction. We need the vertical component here, which is going to be 5 root 2p sine of this entire angle, so 5 root 2p sine theta plus pi by 4, so plus 5 root 2p sine theta plus pi by 4. We're going to call this equation number 1, and we're going to call this equation number 2. Now equation number 1 is sufficient to find the value of alpha, and equation number 2 is sufficient to find the value of beta. So if we take 1, we can see since every single term has a p in it, we can cancel that out, meaning if we take 1, we can cancel out of the p's, leaving us with alpha equals, and on the right hand side we have 3, and then this plus minus can become just a minus, so we have minus 2 root 2 times cosine of pi by 4, which is 1 over root 2. So times 1 over root 2 plus 3 root 2p times, actually not 3 root 2p, just 3 root 2 times cosine of pi by 4, which is going to be plus 3 root 2 times 1 over root 2. And then next we have minus 5 root 2 times cosine of theta plus pi by 4. Now cosine of theta plus pi by 4 we don't know directly, but we can find it from the formula of cosine of a plus b, which is cosine a cosine b minus sine a sine b. So therefore what we have is minus 5 root 2 times the cosine of theta times the cosine of pi by 4 minus the sine of theta times the sine of pi by 4. Now simplifying this down, we get that alpha is equal to 3. This is going to become minus the root 2 and 1 over root 2 cancel to give us minus 2. So minus 2, minus 2, and then this plus 3 root 2 times 1 over root 2 is going to give us plus 3. And then this thing is going to become minus 5 root 2 times, and we can substitute into here. We know cosine of theta, sine of theta, and we know cosine of pi by 4 and sine of pi by 4. So cosine of theta was 4 over 5 and sine of theta was 3 over 5. Substituting into here, we have 4 over 5 times 1 over root 2 minus 3 over 5 times 1 over root 2. Now simplifying down, we can see we get alpha equals 3 minus 2 is 1 plus 3 is 4 minus 5 root 2 times all of this. We have a divide by 5 here and here, so we can divide that by this, and we have root 2 times 4 over root 2 minus 3 over root 2. Cancelling out the 1 over root 2's, we are going to be left with 4 minus 3, which is going to be 1, so we have minus 1. So therefore what we have here is 4 minus 1, which is 3, and therefore alpha is equal to 3. We've solved for alpha. Now similarly, if we take beta and we take equation number 2, from equation number 2, we get that beta, if we divide everything by p, beta is equal to, and on the right hand side, when we divide everything by p, we have 3 plus 3 root 2 times 1 over root 2. So we have 3 plus 3 root 2 times 1 over root 2 plus, and then the next term is 2 root 2 times 1 over root 2. So plus 2 root 2 times 1 over root 2. And then the next term is going to be plus 5 root 2 times the sine of this angle, which we don't know, but we can use the formula for sine of a plus b to say that the sine of theta plus pi by 4 is going to become sine of theta cosine of pi by 4 plus the cosine of theta times sine of pi by 4. So therefore we get plus 5 root 2 plus 5 root 2 times the sine of theta times the cosine of pi by 4 plus the cosine of theta times the sine of pi by 4. Now once again, we can simplify this down using the values that we know, and this is going to give us that beta is equal to 3 plus 3 root 2 times 1 over root 2 is going to become plus 3, 2 root 2 times 1 over root 2 is going to become plus 2, and 5 root 2 is going to be multiplied by 5 root 2 is going to be multiplied by, on the inside here, sine theta was 3 over 5 times 1 over root 2 plus cosine theta was 4 over 5 times 1 over root 2. And then when you simplify this, the 1 over root 2's cancel for the outside root 2. The 5's cancel for these 1 over 5's, leaving us with 3 plus 4 inside of the bracket, which is 7. So therefore, beta is equal to 3 plus 3 is 6, plus 2 is 8, which is going to be 8, plus the thing on the inside, which is 7, which is 15. And therefore, beta is equal to 15. So there we go. We've solved for alpha and beta. Alpha is equal to 3 and beta is equal to 15. Now finally, we can solve for m. Now considering m, if m is the total moment of the entire system, then if we take a moment inside of this system, we should get the same exact value. Now taking moments, one of the easy points I can take would be, let's say, what are some easy points to take moments about? If we take moments about the point D, then both this force, and this force will all be cancelled out, leaving us with only this force 3p and this force of 5 root 2 to worry about. So I think we'll take moments around that point. So if we do that, we have a 3p force at a distance of 2 root 2a, and we have the 5 root 2p force at a distance that we need to figure out. We need to figure out this perpendicular distance here, but I think we'll probably be able to figure it out. So if we go down, we can say that taking moments around the point D, if we take moments around the point D, we're going to get 3p multiplied by 2 root 2a in the anticlockwise direction, so that's going to be positive. 2 root 2a, 2 root 2a times 3p, and then this other force of 5 root 2p is also going to give us anticlockwise moment, so it's going to be positive. We have 5 root 2p times the perpendicular distance, which is, in this case, if I draw the triangle, it's going to be this distance. Now considering the triangle, we can see the hypotenuse of this triangle is 4a, and this side length is going to become 4a sine theta, and sine theta is 3 over 5. So therefore, if we substitute that into here, this distance is 4a times 3 over 5, and then that has to be multiplied by 5 root 2p. So therefore, if we go down and we use this fact, we can say that the moment from that force is going to become plus 4a times the sine of theta times 5 root 2p. Now, combining all of this together is going to be equal to 2 root 2a times 3p is going to become 6 root 2ap. And then the second part, This is 4a times 3 over 5 times 5 root 2p, which is going to give us 6 root 2ap plus, and over here, if we take everything, we're going to have this divided by 5 and this 5 cancelling, and then we're going to be left with 4a times 3 times root 2p, which is going to give us 12 root 2 ap. So 12 root 2 ap. So the total moment here is going to become 18 root 2 ap. Now the moment that we've calculated here is the moment in the original system of forces. That is, before we did any simplifications, the moment that was there in the original system of 5 forces that we had. So this is this moment in the original system. Now we have made an equivalent system, as in a system that will do the exact same thing. So if the system of forces here that we made is equivalent to the original system of forces, then the moments around the point that we took, which in this case was D, should be the exact same in this system of forces. Therefore, if we consider the point D here, and we take moments about D in this system of forces, we should get the exact same moment as we got in this system of forces. Now considering the moments here, we have two forces, beta p and alpha p. Beta p, however, goes through the point D, so it gives 0 moment. However, the force alpha p is perpendicular, which means that there will be a moment through the point D due to alpha p. Now to find that moment, we need to consider distance between D and A, and we know that distance to be 2 root 2a. So therefore, the moment through the point D in the anticlockwise direction due to alpha p is going to be alpha p times 2 root 2a. Now additional to this, there's another moment that is there globally, and that is the moment m. So due to this, the total moment around the point D in this system of forces is going to be 2 root 2a times alpha p plus m, and that moment should be equal to the moment that we found here. So going down, if we write down the moment, if we take the moments around the point D, this time for the new system of forces, we're going to get 2 root 2a multiplied by alpha p. Since alpha is equal to 3, we have to multiply by 3p, and to that we have to add the anticlockwise moment m. And this is the total moment that we have in the new system. Simplifying down, this can be simplified to 6 root 2 ap plus m, which is the moments in the new system, or the equivalent system. So if these two are equivalent, we must have that the moment here is equal to the moment here, and therefore we can say 6 root 2 ap plus m must be equal to 18 root 2 ap, and therefore m must be equal to 18 root 2 minus 6 root 2, or 12 root 2 ap. And therefore we have found the value of m. So we found the value of m, we found the value of beta, and we found the value of alpha. Now after this, the question says, now a couple acting in the plane of the quadrilateral is added to the above system of forces such that the resultant of the new system of forces goes through the point D. Now given this, we are asked to find the moment of the couple added. Now considering what we have to do here, we have a resultant force in this system, and we need to move that resultant force all the way to the point D. Now normally when you have a resultant force and you want to move it somewhere, what you do is to add a couple like this. Now in this case, if we want to move the resultant force to the point D, then we must have the vertical and horizontal forces moving through the point D. So we should have beta p here, and we should have alpha p here. Now additionally, there should be 0 net moments, meaning that this moment of m must also be cancelled. So if we cancel that moment m, then we can see, in order to move these forces that are here at A to the point D, all we have to do is to move the point alpha p, the force alpha p rather, to the point D. Now considering that, since we don't have to move beta p since it's already passing through the point D, to move alpha p to the point D, we need to add an alpha p here and another alpha p here. And that means we need to add a total moment of alpha p times the distance between these two of 2 root 2a. So we need to add 2 root 2a times alpha p, but in addition to that, we also need to cancel out the moment that was already there previously. So therefore, the total moment we need to add is the sum of this moment here and the moment created by moving alpha p from this point to this point. So basically, the moment created by adding a negative alpha p at the point A and a positive alpha p at the point D. So therefore, the total moment, if we add a total moment, let's say we had a moment of m1 or something, then m1 must be equal to the moment m plus the additional moment in the clockwise direction needed to get rid of all of the moment caused by this alpha p force at the point A. So basically, we need alpha p times 2 root 2a plus the moment m. So if we do that, if we go down and write that down, we can say that if the moment needed to be added is m1, we'll go down here and we'll say something like if the moment to be added in the, let's say, clockwise direction, because we know it has to be clockwise, the clockwise direction is m1. That is, and we'll actually draw the diagram here just to give a better idea of what we're actually doing. If we consider this system of forces, we are going to copy this whole thing and we're going to take it down. We're going to copy like this. We're going to take it down here, and to this system of forces, we're going to add another force, another moment rather, of m1, such that this is equivalent to the point D having a force upwards of beta p and a force sideways of alpha p, and there's nothing else here. If this is equivalent, then we must have the case that m1 moment is equal to, as we discussed, m moment plus the moment required to move the force of alpha p from the point A to the point D, which is going to be, if we put alpha p here, and an alpha p at D, we can see the moment required is alpha p times 2 root 2a. So therefore, we need to have m1 equals m plus 2 root 2a alpha p. So therefore, substituting m1 must be equal to, m is equal to 12 root 2ap, and to that we need to add 2 root 2a times 3p, which is going to be 12 root 2ap plus 6 root 2ap, which is going to be a total of 18 root 2ap, and therefore the total moment required is 18 root 2ap, and that is the final answer to our question. So now let's finally go over the marks awarded for this question. So at the start of the question, when you find sine of theta and cosine of theta, which are relevant and necessary geometrical facts in order to solve the problem, you get 5 marks. After this, when you resolve in the horizontal and vertical directions, when you write down the equation that you get when resolving for the horizontal direction, you get 10 marks. And similarly, when you write down the equation you get when you resolve in the vertical direction, you get another 10 marks. Now, when you simplify these two, for substituting cosine of theta plus pi by 4 as cosine of theta cosine of pi by 4 minus sine theta sine pi by 4, you get 5 marks. And for substituting in the relevant trigonometric values, you get 5 marks. And then for finding the final answer of alpha as alpha equals 3, you get another 5 marks. Now similarly for beta, when you substitute in sine of theta plus pi by 4 as sine theta cosine pi by 4 plus cosine theta sine pi by 4, you get 5 marks. And when you substitute in the relevant trigonometric values, you get another 5 marks. And finally, when you get the correct answer, you get another 5 marks. Now for finding the moment m, when you take moments around any point, they've taken in the marking scheme the moments around A, but you can of course take around any point. I've taken around D. When you take moments like that and write down the equation that you get 15 marks. And then when you use the equation to eventually solve for m and get m equals 12 root 2 ap, you get another 5 marks. Now for the final part of the question, when you find the equivalence like this and you say that if these two systems are equivalent, then m1 must be equal to m plus 2 root 2a times alpha p, you get 10 marks. And when you solve for m and find that m is equal to 18 root 2ap, you get another 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback, post in the comments down below. Thank you for watching and goodbye.